Good morning to all. I am K.R. Ulagu, Assistant Professor of Chemistry, J.J. College of Arts and Science, Pudukkottai. Now, I am going to discuss about introduction, classification, preparation and purification of colloids. Introduction to colloids. Colloids like a solution. What is a solution? Solution is a mixture of solid plus solvent. It can be homogeneous mixture or heterogeneous mixture. What is homogeneous mixture? It will have uniform amount of solution. We call it true solution. Homogeneous mixture is based on particle size diameter is less than 1 nanometer. Particle size is very small. Sugar and salt solution. These are some examples. What is heterogeneous mixture? It is not uniform. We call it suspension solution. Heterogeneous mixture is based on particle size diameter is more than 1000 nanometer. Particle size is very large. Sand in water. This is example for suspension solution. What are colloids? Intermediate between true solutions and suspension solutions are called as colloids. The particle size are between true and suspension solution 1 to 1000 nanometer. Cream, butter, milk, these are some examples. Colloids consist of two phases. One is disposed phase, another one is dispersion medium. What is disposed phase? Particles which are disposed in medium. What is dispersion medium? It is the medium in which particles are disposed. Colloids are classified on the basis of two. First one is physical state of disposed phase and dispersion medium. Second one is nature of interaction between disposed phase and dispersion medium. Let's start first classification. Physical state of disposed phase and dispersion medium. There are three physical states: solid, liquid and gas. Gas to gas is not exist. All gases are mutually miscible. So, there are 8 possible colloidal systems. Solid particle in solid medium. This is called solid salt. Solid particle in liquid medium. This is called solid emulsion. Solid particle in gas medium. This is called solid foam. Liquid particle in solid medium. This is called salt. Liquid particle in liquid medium. This is called emulsion. Liquid particle in gas medium. This is called foam. Gas particle in liquid medium. This is called aerosol liquid. Gas particle in solid medium. This is called aerosol solid. The next is nature of interaction between disposed phase and dispersion medium. Colloidal salts are divided into two types. First one is lyophilic colloids. Second one is lyophobic colloids. What are lyophilic colloids? This is reversible process. Colloidal particles attract their solvent. Lyophilic solution easy to recreation just by mixing. Gelatin, gum, starch, these are some examples. What are lyophobic colloids? This is irreversible process. Colloidal particle has little attraction to the solvent. Gold, silver, their sulfides, their oxides, these are some examples. Hydrophilic salt or hydrophilic colloids. Hydrophilic colloids are water-loving colloids. The colloidal particles are attracted towards water. Hydrophobic salt or hydrophobic colloids. Colloidal particles does not interact with the water. Difference between lyophilic and lyophobic salts. Properties. Reduction of particles. Lyophobic salts. The particles may be readily detected by means of an ultramicroscope. Lyophilic salts. The particles are not detected by means of an ultramicroscope. Properties. Viscosity. Lyophobic salts hardly differ from that of the disposal medium. Lyophilic salts much higher than that of the disposal medium. Properties. Electric charge. Lyophobic salts. All particles in a salt have the same charge resulting from the adsorption of ions from solution. Lyophilic salts. The charge on colloidal particles depends upon the pH of the medium. Since the particles readily absorb hydrogen ions or hydroxide ions, this charge is often due to the dissociation of the molecules of the disposed substance. Properties. Migration of the particles in the electric field. Lyophobic salts. The particles migrate in one characteristic direction depending on the charge they bear. Lyophilic salts. The particles may migrate in either direction or may not migrate at all, depending on the pH of the medium. Properties. Stability. Lyophobic salts. Disposed particles are precipitated by the addition of small amount of an electrolyte. Lyophilic salts. Disposed particles are not precipitated by small amounts of electrolytes, although large quantities cause precipitation. Properties. Nature. Lyophobic salts. When the liquid is removed, the resulting solid does not form salt again by the simple addition of the liquid. Lyophilic salts. When the liquid is removed, resulting jelly-like solid is reconverted into salt by the addition of the liquid. Properties. Occurrence. Lyophobic salts generally do not occur naturally. Lyophilic salts. Most of these occur naturally. The next is preparation of colloids. We have two main types of methods for the preparation of colloidal solutions. First one is dispersion method. Second one is condensation method. What is dispersion method? Large particles broken into colloidal size particles. We use different dispersion method. First one is mechanical dispersion. Second one is electro dispersion. Third one is ultrasonic dispersion and also peptidization. Mechanical dispersion. The substance to be disposed is ground as finely as possible by the usual methods. It is shaken with the dispersion medium and thus obtained in the form of a coarse suspension. This suspension is now passed through a colloid mill. The simplest type of colloid mill, called disc mill, consists of two metal discs nearly touching each other and rotating in opposite directions at a very high speed. The suspension passing through these rotating discs is exposed to a powerful shearing force and the suspended particles are apart to yield particles of colloidal size. Colloid mill are widely used in the industrial preparation of paints, cement, food products, pharmaceutical products. The next is electrodispersion. Electrodispersion method, also called as Briggs arc method. Metal particles are broken into case colloidal size particles. These methods are employed for obtaining colloidal solutions of metals like gold, silver, platinum. An electric arc is struck between the two metallic electrodes placed in a container of water. The intense heat of the arc converts the metal into vapors, which are condensed immediately in the cold water bath. This results in the formation of particles of colloidal size. We call it gold salt. The next is ultrasonic dispersion. We use hydrosol of mercury. Ultrasonic vibrations bring about the transformation of coarse suspension to colloidal dimensions. Class obtained mercury salt by subjecting mercury to sufficiently high frequency ultrasonic vibration. The next is peptidation. Peptidation is the process of converting a freshly prepared precipitate into colloidal form by the addition of a suitable electrolyte. The electrolyte is called peptidizing agent. For example, when ferric chloride is added to a precipitate of ferric hydroxide gets converted into reddish brown colored colloidal solution. This is due to preferential adsorption of cations of the electrolyte by the precipitate. When ferric chloride is added to ferric hydroxide, ferric ions from ferric chloride are adsorbed by ferric hydroxide particles. Thus, the ferric hydroxide particles acquire positive charge and they start repelling each other, forming a colloidal solution. Now, the next method is condensation method. Small particles aggregate to form large colloidal particles. Sulfur salt is obtained by hydrogen sulfide gas passing through the solution of an oxidizing agent like a nitric acid or bromine water. Bromine react with the hydrogen sulfide in the formation of sulfur salt. Then nitric acid react with hydrogen sulfide in the formation of sulfur salt. Ferric hydroxide salt, arsenious sulfide salt can also be prepared by chemical methods. The next we discuss about purification of colloids. When a colloidal solution is prepared, it contains certain impurities. These impurities are mainly electrolytic in nature and they tend to destabilize the colloidal solutions. Therefore, colloidal solutions are purified by the following methods. First one is dialysis method and second one is electrodialysis method. Dialysis method. What is dialyzer? This apparatus used to purify the colloidal solution using dialysis method is called dialyzer. Membrane are used. These membrane are having very small holes. It contains colloidal solutions. It's suspended in the vessel. Fresh water continuously going and the molecules, impurities and ions they will diffuse the membrane. But colloidal particles will not diffuse. The impurities diffuse out leaving pure colloidal solutions in the bag. This process of separating the particles of colloids from impurities. The next is electrodialysis method. The dialysis process is slow and to speed up its rate, it's carried out in the presence of an electric field. When the electric field is applied through the electrodes, the ions of the electrolyte present as impurity diffuse towards oppositely charged electrodes at a fast rate. The dialysis carried out in the presence of electric field is known as electrodialysis. Thank you.